All right, welcome back. So last topic I want to talk about here is atmospheric pressure. So atmospheric pressure is the pressure caused by air molecules acting on an object above the Earth's surface. So a couple of quick facts for you. Normally we don't notice atmospheric air pressure because the pressure inside our bodies balance the outside pressure. When do you kind of feel it? Well, on a plane, what happens? Your ears pop, or if you go up and down steep hills or mountains, so pop. So that's how we deal with it in our bodies, is when that air pressure change does occur, we notice it with our ears popping. And it only happens for us when we do extreme altitude changes. Atmospheric pressure is measured in kPa, kilopascals. That's what I talked about in the last video. It's standard atmospheric pressure. Okay, that's what we experience on average. What you're experiencing roughly right now is 101.3 or 101.3 kilopascals. So a relationship, just quickly, if this is our ground level right there, so just scroll down. So we're going to identify this as ground level, or sea level, I guess is the official term, so let's use that. So that's where we're at right now. Okay, so that's sea level, and there's 101.3. So there we are right there. There is the relationship with atmospheric pressure in kilopascals. Now, as we get higher, that pressure decreases like that. And if we go lower, if we go underwater, theoretically, it'll go like that. All right, and it's because of the higher the altitude. Okay, higher the altitude. There's a decrease in gravity. Okay, decrease in gravity, which causes the following. So it's kind of a domino effect here. So if we go higher, like we talked about in Unit 2, the higher we go, the less gravity acts on us with Earth. Well, it's less force acting on air molecules. Alright, so when we go higher, gravity acts less not only on us, but also on the air molecules, which allows the air molecules to spread out more. Can spread out, which results in a lower pressure. Alright, so as you go higher, air pressure decreases, and it's because of a combination of things, but for the most part, it's that pressing of air molecules on you. There's less up there, so your pressure would decrease. Alright, so the last thing I want to talk about is how does a drinking straw work? Alright, so if you want to sketch in a drinking straw under the water here. So what's happening in this situation here? Well, right now, the water is up to, inside the straw, is up to the water level that is the same as the water level in the glass. So what's happening is that the atmospheric pressure is pushing down on the water surface. All right, so atmospheric pressure. Okay, so it's pushing down the surface of the water. Now, what happens when you put your lips on the straw, what you are doing when you suck is that you are removing air molecules. Oops, removing air molecules. Removing air molecules. When you suck. I'm going to put that in quotes. There we go. All right. So when you remove the air molecules, you essentially create a vacuum. Create a vacuum. All right. So when you remove your air particles from there, what happens then is that the air pressure from atmospheric pressure pushes the water to fill that void. All right. So air pressure pushes the water up the straw to fill the void. All right, so you're not actually sucking the water up the straw. You are removing the air particles that were in the straw, and when you do that, air pressure, atmospheric pressure pushing down the water surface, forces the water up the straw into your mouth. So if we didn't have atmospheric pressure, so if we were in a vacuum and you try to use a straw, it wouldn't work. You need that atmospheric pressure to push the water up the straw so you can actually have a drink. All right, so that's how a drinking straw works. A lot more complicated than you originally thought. So you are acting as a pump. That's what you are essentially acting as when you when you're working or sucking on the end of a straw. You're acting like a pump, an air pump, and you're just removing the air out of the straw. That's all you're doing. Then what happens is once you've removed the air out of the straw, atmospheric pressure can take over and push that liquid up into your mouth. All right, so there you go, practical application that you do maybe every day, and that is the first lesson. Any questions? You know where to find me. Good luck.